And notice I left a strategic place in there because I know what I'm going to be doing. I'm going to be completing the square, right? These guys are the first two terms of a perfect square. And a perfect square has 1, 2, 3 terms, so I'm going to leave that last term space blank because I know what I'm going to do now. And that's my next step. Complete the square. So what to do? What do I do with this 4?
To have it.
Half of it, absolutely. That's 2, and then what? Square it to get the term to always be positive. Plus somebody got a thought?
Remember from which middle?
Somebody got an uneasy feeling right now based on what I just did? Somebody should be having some mathematical indigestion right now because of what I just did.
I think the answer was to equal 0.
I just violated one of the primary rules. Thank you very much. Yes, I do. Ladies and gentlemen, I just added 4 to one side of the equation. It ain't an equation anymore unless I add 4 to the other side. Right? And just go around adding 4 to one side of the equation and still try to pretend like it's an equation. You do that, you can run for political office. But we don't do that in this class. We add 4 to one side, we add 4 to the other. Right? That's kind of basic. Don't forget it. When I complete the square, I am, in essence, adding something to one side of an equation. So add it to the other as well. So let me put that down in parentheses here. Add to both sides. Notice I invested extra ink in 2 exclamation points. If you don't do that, yeah, blue. All right, number 3. Now, if I truly have a perfect square, then I have something squared. Right? We were practicing doing that a little earlier. Hey, if it's a perfect square, it can be expressed as, in parentheses, something squared. Okay, this is what squared. Square that, sine of that, square that, absolutely, x plus 2 squared. Now you know where we're going, I'll bet you, because this looks an awful lot like the problem in the section right before this. Our next step is use square root property. Yeah, I can use the square root property, right? I got something squared equals a number. That's set up for the square root property. What do I do to use the square root property?
Square both sides.
Square both sides. Square that, square that. Get x plus 2 equals, what do I get? Thank you for that plus or minus. And I don't even have to tell you we're not going to leave it that way. That means x plus 2 equals 6, or x plus 2 equals negative 6. X is 4. Or x is 8. We okay with that? Hey, let me give you a little pointer here. If you use the square, complete the square method, everybody watch. When you get whole numbers, that means you put a factor to start with. Sometimes you're not going to see significant factors. Some of you probably saw that original trinomial factory. Most of us didn't even think about it. Why? Because the problem said solve it using the complete the square method. So we didn't even think that it could factor. And maybe you looked at it on the test, you're going, I don't think it factors. I think I'll use one of the methods that always works. And you complete the square and got the right answer. Either way, same answer. So if you see it factors, factor it. If you don't, there are other ways to do it, right? Speaking of which, this method works every single time. Did y'all hear that? Factoring method only works when it's factoring. Square root property only works when it's something squared equals a number. Completing the square works every single time. So if you want to put all of your quadratic eggs in one basket, this is a good basket to put in, because it always works. This method and the next method always work. You probably know what the next method is, right? The quadratic formula, yeah. Well, let's go ahead and do one more of these, because these are kind of a little bit... let's do one that doesn't factor. You think that's gonna factor? No. That's not gonna factor. Two numbers that multiply to get negative 11, add to give 6. Good luck. So it's not gonna factor. Can you use the square root property on that? Is that something squared equals a number? No. Yeah. So method 1, method 2, don't work. So I'm left with either method 3 or method 4. Let's do method 3. Let's complete the square. Step 1, all x stuff on one side. Okay? Step 2, complete the square. What am I going to do? Okay. Square it. Thank you. Add 9 to the other side as well. All right, let me point out something to you, ladies and gentlemen. Everybody look here. What if that was 5x? When I take half of it, I get 2.5, and then when I square that, I get problems, right? So here's my point. If you run into fractions like that, and you start squaring fractions, go on to method number 4. All right. Completing the square, you should only use completing the square if it works very naturally and neatly. In other words, if I have a 1 in front of the x squared, and if I have an even number in my x's. Otherwise, don't bother about it. You're going to run into fractions, squaring fractions. It's not going to be pretty. So work it this way when it works nicely this way. So here's what I got. I got something squared equals 20. Can somebody tell me what that is on the left?
X plus 3.
Got it. X plus 3 squared equals 20. Now what do I do?
Square both sides.
There you go. Square both sides. Square root property. X plus 3 equals?
Plus or minus the square root of 20.
Here's where you should have a retro thought back to section 2 or 3 of chapter P. Square root of 20. Is that